Welcome back, students. You made it through the midterm. Some of you really struggled on the midterm. Others did very, very well on the midterm. So if you're in the group that struggled to do well, all is not lost. Continue to work in the course, making sure you're focusing the time you need to learn the concepts. And if you need help, come in and see me. I've got office hours, both virtual and online. You're welcome to come see me. Additionally, we offer free tutoring services for you to help you master these concepts. So the expectation is that you do master the concepts that were tested on the midterm. So if you haven't mastered those yet, please do spend the time to master those concepts because they will be needed as we move forward. So if you're struggling, seek help. There are resources to help you. And I wish you much success in that journey. Encourage you to take advantage of those resources. I did receive the question if there's an opportunity to retake the midterm exam, and there is not. The group solve and the learning tasks were designed to prepare you for that midterm, so you knew what was coming. And you might have noticed there's a very, very strong alignment between those two. And so those who didn't do well just hadn't learned the concepts yet that were tested on, that were on both the group solve and the learning test. Okay, but now we're moving into new material. We're on to module number 6. And we're going to now be looking at rate of change functions and how to assess what they tell us about the original function. So let me give you an example. I've got 2 examples here on the board we'll kind of talk through. Here I have the rate of change function for a car traveling down a freeway. You can see this car is traveling at 60 miles per hour. That's a constant rate of 60 miles per hour between hours 1 to 4. So I'm interested in what's going on there. Now, certainly the car was traveling at some speed before that, some speed after that. Yeah, in fact, let me go ahead and draw that in so we don't think that car just instantly started there. So I've got it traveling here at 60 miles an hour. It's continuing. But my interest is what happened between hour 1 and hour 4. Now let's think about what a natural question might be. Would be, well, if this car was traveling 60 miles an hour, how far did it travel between hours 1 and 4? Now, this is pretty intuitive. The change there was, well, 4 hours to 1 hour. That's a 3-hour change. 3 hours times 60 miles an hour. Go ahead and write that here. 3 hours times 60 miles an hour. We can do the multiplication. The hours cancel. 3 times 160. We traveled 180 miles over those 3 hours between hour 1 and hour 4. Notice that this calculation of 3 times 60 is the horizontal distance here times the vertical distance. That is, the area of this rectangle in here represents our miles traveled. So that's a really interesting connection here between the geometry, the rectangle here, and the overall distance traveled. Now let's go over here and look at this case. Again, I'm traveling between 1 and 4, and let me go ahead and say that I did have some speed before and after that. I'm interested in what's going on between 1 and 4. Now, unlike our first example where we were traveling at a constant speed, here I start off at 40 miles an hour and I accelerate up to 60 miles an hour over that 4-hour period. Now, admittedly, that would drive me nuts if we were accelerating that slowly on a freeway. And certainly 40 miles an hour on a freeway is not normal. But let's say it's a backcountry road, okay? But we're able to speed up as we go. So the question is, how far did we travel? Well, this one's a little more complicated. Let's see. If I look at this piece right here, if I were to travel at a constant 40 miles an hour for those 3 hours, that would give me 120 miles. That's just if I were going that fast. That takes care of this area down here, but what about this area here? Well, using that same area thinking that we did over here, I've got a triangle here. This base of this triangle is 3 because it's from 1 to 4 is a distance of 3 hours. The height, well, it was at 40, now it went up to 60. So this change there is 20, an additional 20 miles per hour. And I can use the area of a triangle formula, my base times my height times 1/2. So 3 times 20 is 60, and half of that is 30. So I got an additional 30 miles there in that little piece. So all told, I traveled here on this one 120 miles plus the additional 30. So this one was 150 miles total. If I travel like that. And over here we have, of course, that 180 miles. Well, this is all fine and great as long as the shapes created here are simple geometric shapes. Here we have a rectangle. Here we have trapezoid, which we were able to break into a rectangle and a triangle and do those calculations. But what if it's not as clean as that? So let's look at an example where it's not as clean. All right, so here's a new graph. I've got, again, when we go to label things, I've got hours down here. I've got miles per hour here. We see that my car was starting off at time 0. Whenever we started our clock, we were going 60 miles an hour. But we accelerated up to just over 70 miles per hour. And then we slowed way down, maybe 55 miles an hour. Maybe there was a change in speed limit sign. And I went around 55 for a little bit and then ultimately accelerated back up. Again, maybe we got through that zone where we had to go 55 an hour speeding back up. So the question is, how far did I travel? Now, what we established in our earlier 2 examples is how far I travel is equivalent to asking what is the area of this region in here. Well, that's kind of tough. I can get an estimate, I guess, if I use the rectangle here for the lower part. I could try to estimate with triangles and such, but it's a little trickier. So we don't have a formula that just magically spits it out what the area of this would be. But let's look at a strategy. Since we know the area of a rectangle, what if we do this? What if I start with this value right here? That goes with 1 hour, what my velocity was there, and just continue at that speed over an hour. So look at this rectangle here. So let's look at this one right here. Now, just for estimation purposes, let's say this was at 65 miles an hour there. So I've got this first rectangle, and certainly I can figure out the area of that. It's 1 unit wide and 65 units high. So the distance traveled over this hour, I'm estimating at 65 miles. Now, we know that's an underestimate. We can see there was additional area here, but that's an estimate. Next, we go to this second hour from 2 to 3. I'll go up to the graph again. And let's just say that this point right there is 70. And I'm going to assume I'm going to travel at that 70 miles an hour for a full hour. So there's my hour, and then I go over here. So I'm looking at the area of this rectangle. And 1 hour for 70 miles an hour, so that's 70 miles. Now we know this one is actually an overestimate because we didn't go 70 miles an hour that whole hour. We dropped our speed here, but it's an estimate nonetheless. Over that next hour, we went 70 miles. Now we go up here and say that this value right there was 55. And then I could estimate here, and it looks like 55 for most of the way the whole way. So again, I can go here, 1 hour, 55 miles an hour, and estimate I did 55 miles. Now, if I want to get an overall estimate for that trip between 1 hour and 4 hours, I can add those up. So my distance estimate is 65 plus 70 plus 55. And if I add those values up, what do I get? Let's see. The 65 and the 55, that's going to give me 140 20, and then plus the 70, that's going to give me 190 miles is my estimate. Now notice on these rectangles, the upper left-hand corner of each rectangle touch the graph. So we're going to call this is my left-hand sum estimate. And we also use the term Riemann after the mathematician who developed this. So that we'll say the Riemann sum, the left-hand Riemann sum, or we'll just say the left-hand sum. So I estimated that this car traveled 190 miles over that 3 hours. Well, we could also get a right-hand sum estimate. Let me show you how that would work. I'll use blue for this. So the idea is here, we're going to go over to 2, come up to the graph just like before, but instead of drawing horizontally to the right, we're going to go horizontally to the left. And so now I'm looking at this rectangle right here. So again, all of this in here in blue. So my right-hand sum estimate for this is with the right-hand corner touching the graph was that I went 70 miles. Left-hand sum I said 65, right now I'm saying 70. Coming up here now to my next point right here, then going to the left. So I'm looking at this region down in here. Well, that's 55, and I went for 1 hour. So my estimate is 55 here. Again, that's less than our left-hand sum estimate. And then finally, I'll go up here to this point. Let's just say that's just slightly higher. Let's call that 56. And so I would go over here, and I'm looking at this triangle, and the area of that would be about 56. So notice all of these blue triangles, or rectangles rather, all these blue rectangles, their right-hand corner touches the graph. You know, we got a lot of stuff going on there. So let me redraw that purple graph just so you can still see where it is. Okay, there we go. All right, so let me go ahead and calculate that right-hand sum. That was the blue one. So the right-hand sum would be the 70 plus the 55 plus the 56. So what's that going to come out to be? The 50 plus 50 would be 100, and I get 170 plus the 5 and the 6. That gives me 181 miles. So the left-hand sum estimate was 190 miles. The right-hand sum estimate was 181 miles. So I can reasonably estimate that I went somewhere between 181 and 190 miles on this trip. All right, how could I improve my accuracy of my estimate? Well, I went and grabbed the speed for every hour. What if I grab the speed for every half hour, or every 15 minutes, or every 1/6 of an hour, maybe every 10 minutes, or every 1/12 of an hour, would be every 5 minutes. So what if I made more rectangles? Could I get a better estimate? So we're going to look at estimating total changes, or accumulated changes, if you will, using these left and right-hand sums. We'll now dive into an example from our worksheet for today, where we're not given the graph, we're just given a table of data. We're going to have to infer what the graph looks like from our data, and then try to construct those left and right-hand sums. So here's the situation we have. This is water flow rate. And we have this. We have time, which is measured in minutes. Then we have the flow rate, which is measured in liters per minute. And I've got these values. At time 0, the flow rate is 12 liters per minute. 5 minutes in, the flow rate is 15 liters per minute. 10 minutes in, the flow rate is 18 liters per minute. 15 minutes in, the flow rate is 20 liters per minute. And then finally, 20 minutes in, the flow rate is 21 liters per minute. And so I'm supposed to get an estimate for the accumulated volume over this 20-minute period with this variable flow rate. So this is like water flowing into a tank. So how might I do that? Well, let me go ahead and draw a rough sketch just to give myself an idea of what's happening. Let me go ahead and sketch these points to get an idea of what this might look like. I'm going to call this up here 24. If I cut that in half, that would give me 12. If I cut that in half again, that would give me 18 there. Cut that in half there, that would give me 6. And maybe I'll cut those in half. That gives me 3 and 9. Gives me what? 15 in there, and then 21 in here. Now I'm going to need to go out to 20. Let's call this 20. Cut that in half, I get 10. So that'd be 15 and 5. These are minutes over here, and these are liters per minute up here. Let me go ahead and plot those points. At 0, I'm up at 12. At 5, I'm at 15. So 5, I'm at 15. 10, I'm at 18. 15, I'm at 20, so just shy of that 21. And then at 20, I'm at 21, so just a little bit higher. So I don't know exactly what it looks like, but this is my guess of the pattern we might be seeing in the flow rate. All right, for left-hand sum, let's see which heights we are interested in. Remember, we go up to the graph and then go to the right, whatever our interval is here. Here we can see the interval is 5 minutes. So I go over, up. Oops, so we're going to pretend that's straight. And I've got a 5-minute interval at 12 liters per minute. 5 times 12, I get 60 liters for that 5 minutes. Now we go up here, and again, I'm now at 15. Move over. For those 5 minutes, I went 5 minutes times the 15. That gives me 75 liters for the next 5 minutes. Now 10 minutes, I come up to the graph. Sorry, I'm a little off on my sketching here. Go for 5 minutes. Looks like my original points were a little off. Fix that. So my height there is 18. 5 minutes times the 18 is 90 liters. Sorry, my thing's not drawing the scale. My apologies. Next, we go up to, what was the next height? 20. I'm at 20 for 5 minutes. We get 5 minutes times the 20 liters per minute, and that gives us 100 liters. So notice the heights I ended up using for my left-hand sum were this one, this one, this one, and that one. The last value, that last height was not used at all. So for my left-hand sum, I had 5 times 12, which was the 60, plus 5 times 15, plus 5 times the 18, plus 5 times the 20. Now notice we can be more efficient in our calculations if we just take 5 and multiply the sum of those heights. So we don't have to multiply by 5 each time. We can just add these up and then multiply the result by 5. All right, let's see what we've got when we add those up. 12 plus 15 is going to give me 27. 27 and 8 would be 35. 45 plus another 20 is going to be 65. So we get 5 times 65, and that totals 325. If I did my math right, let's make sure. 5 times 60 would be 300, and then 5 times 5 is 25. So we estimate that 325 liters was used, flowed into that tank. That's our left-hand sum. Now let's do the right-hand sum. Now I'm not going to draw the right-hand sum, but let's see if we can reason through how it might look. Remember, for the left-hand sum, all these left-hand corners touch the graph. For the right-hand sum, we're going to start here and then go that way, right? We're going to use all of these heights. So notice the heights are determined not by these first 4 values, but by these last 4 values. You can see the height here. This one was 15. So I can create my right-hand sum now. I'll use this space up here to do that. The right-hand sum, well, the width of these rectangles is still going to be 5. Again, I can improve my accuracy if I may narrow that width. But we'll go with this, and then we'll go add up these heights. So it's going to go from 15 plus 18 plus 20 plus 21. It's 5 times. So let's see what this adds up to. So if I do the 15 and the 21, that gives me 36. If I do the 18 and the 20, that gives me 38. So I'm doing 36 plus 38. That's the same as 37 times 2, which would be what? 74. 5 times 74 is the same as 10 times 74 divided by 2. 10 times 74 is 740 divided by 2. Would give me 370 liters. So my estimate in terms of water flow, that between 325 liters and between 370 liters of water flowed into the tank over this time period from 0 to 20 minutes.